video we'll be talking about linear regression. Recall that the equation of a line is given by y is equal to b0 plus b1 times x, where b0 is equal to the intercept and b1 is equal to the slope. And so, just to give you a few examples of us toggling the intercept and slope, I'm going to create these plots. So in our first plot, we're going to have our intercept b0 equals 0 and our slope b1 equal 0 as well. This equates to a line as drawn here, where the y-intercept, which is b1, is equal to 0, and so the line cuts the y-axis at 0, and the slope b1 is equal to 1, and so this line is flat. And so it's lying directly on the x-axis with no slope, or slope of 0. And so what would a line look like that has an intercept again of 0 and a slope b1 of 1? That line would look like this. So once again, it cuts the y-axis at 0, but now the slope is positive. And an example of a line with b0 equaling 1, the intercept being 1, and b1 equaling 1 is this line right here. So if we have 1, 2, 3 on the y-axis, we now cut the y-axis at 1, and the line has the same slope as the previous plot. So just to give you another example, or two other examples real quick, then if we had b1 is equal to 1, or let's say b0 is equal to 1 and b1 is equal to 2, then we'd have a line that cuts the same exact location as the previous plot. But let me draw this a little better. Notice how this line is steeper than the previous line, than the yellow line. And then if we have one more example where b0 is equal to -1 and the slope b1 is equal to -1, we'll then have something like this. -1, we'll be cutting the y-axis, and the slope is now negative. So the line would look like this. And so now we have a firm grasp on how toggling the intercept and slope changes the line. Suppose that we had a data set that consisted of, so I'm going to just draw the data set on a plot. Let's say we measured the amount of water that we gave to plants. So water's on the x-axis, and then the plant length is on the y-axis. And then so we have a set of values for the daily amount of water that we give the plant, and then we have number of values for the plant length. Let's say we had something along the lines of this right here. Let's say this is our data. And so what regression seeks to do is to basically create a line. Y is equal to b0 plus b1. And when I say create a line, I mean so linear regression finds b0 and B1, and I'm going to just put in brackets coefficients. Such that the distance between the line and the data points are minimized. And so I'm going to now give an example of a good fit and a bad fit. And so a good fit would be a line, so this line right here. And a bad fit would be, for example, this line right here. And the reason being is that if we drew the distances between these lines and the data points, so if we looked at the distances for the blue line, these distances are given by these lines right here. You could see that these distances are a lot less than if we were to take the data points and draw the distance to the red line, which is given by this. And so regression would find the coefficients of the blue line. That is the line that minimizes the distance between the data points and the regression line. And so this is an overview of linear regression, and thanks for watching.